Welcome to the debate. Today, we're diving into the A320 family. It's obviously a global workhorse, but it's recently been the focus of some concern. We're seeing a mix of technical incidents and, well, frankly, massive operational expansion plans. We've got three key things from recent briefings to consider. First, there was that significant hydraulic malfunction on an A320neo over the Tasman Sea. Second, a really troubling reduced separation incident in India airspace, which seems directly linked to air traffic control failures. And third, Airbus's pretty aggressive plan to ramp up production, symbolized by the new Tianjin Final Assembly Line, the FAL. So this all leads to a crucial question for the future. Where does the greatest challenge to the A320 family's continued safety and reliability actually lie? Is it in managing the inherent sort of technical risk within the aircraft itself? Or is it the systemic operational risks that are growing because of our increasingly complex and, frankly, congested global airspace? Now, I'll be arguing that technical failure and the pilot response, the vigilance needed, that remains the paramount concern.
And I'm going to take a different tack here. I disagree on where we should prioritize that risk. Look, no one's denying the importance of technical integrity. That's obvious. But I think the dynamics have fundamentally shifted. For a platform like the A320, which is mature, high volume, well, the systemic operational risks, those factors outside the airframe, they are, I believe, rapidly becoming the dominant threat profile. The focus really needs to move from just component reliability to the robustness of the whole infrastructure.
Okay, let's look closely at that Air New Zealand A320neo incident, flight NZ221. This aircraft, it's one of the newest variants, a Neo, right? It's got modernized systems, new engines, yet it experienced a major hydraulic malfunction, had to divert to Sydney. This incident, for me, fundamentally proves that even with decades of design maturity, even with cutting-edge tech, technical risk is just inherent.
It's unavoidable in complex machinery like this. And the core insight from the report was, and I quote, that the crew's rapid response and calm handling prevented escalation. They were the final, absolutely crucial safety barrier. Sure, we build in redundancy, multiple hydraulic systems, advanced flight controls, but complexity itself breeds unexpected failure modes. So therefore, the priority has to be focused inward, rigorous aircraft maintenance to minimize the likelihood of technical failure, and then really highly skilled crews who can intervene effectively when the machine, inevitably falters sometimes. That's where the ultimate safety margin really resides.
I understand why you emphasize the pilot's role there, especially in recovering from a technical failure. But doesn't that framing sort of overlook the fact that the A320 is designed for technical redundancy?
The reason it could land safely is precisely because of those built-in internal systems.
Well, yes, but
So for me, the more profound threat, the one that's maybe harder to predict and manage, it comes from outside the aircraft's skin. I'm thinking specifically about that Air Arabia A320 incident over India airspace. It came way too close to a Boeing 777F freighter. And that near miss, it wasn't some mystery. It was explicitly traced back to controller workload and specific handover shortcomings between controllers. That's a clear systemic environmental failure. And as Airbus ramps up production, Tianjin being the latest FAL example, the resulting surge in A320 family aircraft just exacerbates the pressure on global air traffic control infrastructure. An infrastructure that, let's be honest, is already struggling in many places. This exponential increase in traffic density, route complexity, it makes external systemic failure the leading vulnerability in my view. We're shifting from managing the machine, which we're quite good at, to managing the environment it operates in, which is proving much trickier.
Core debate. Okay, let's maybe try and define our terms a bit here. Specifically, this idea of robust systems. When the briefing materials discussed that India airspace incident, they explicitly called out the need for robust systems, right? But it was in the context of operational failures, meaning ATC handover protocols, controller staffing, flight information architecture. That points directly to a structural deficiency in the operational environment. Now, you're proposing that robustness starts in the cockpit, but
how can focusing solely on crew vigilance possibly address controller workload issues or cross-jurisdictional handoff problems happening hundreds of miles away? The crew has essentially zero control over those environmental variables.
Okay, fair point. I acknowledge the explicit call for ATC improvement, absolutely. But I think the definition of robustness, or maybe where it starts, has to be earlier in the chain. A truly robust overall system, it begins with a highly reliable platform, the aircraft itself, and a crew capable of managing a crisis when it occurs. Think about it. The NZ-221 crew were the robust system in that moment. They contained the failure. They prevented a component failure from becoming a catastrophe. If the airframe itself can't sustain flight after a single component failure, well then no amount of ATC efficiency downstream is going to matter, is it? Furthermore, the environment you describe, controller workload, differing regional procedures, that's inherently less predictable, less, dare I say, robust than the certified technical envelope of the aircraft. When we design hydraulics, we define precise parameters, failure modes. When we design airspace management, we're introducing vast human and regulatory variability. So the technical system is, maybe paradoxically, the more dependable baseline to start from. A dependable baseline isn't really enough, though, when the system it operates within becomes saturated, or worse, unpredictable. And consider the geopolitical dimension here, which is inherent in operational risk, a dimension completely absent from, say, a hydraulic failure. The A320s rolling out of Tianjin, they're flying into incredibly diverse regulatory spaces, different levels of infrastructure investment. That reduced separation incident wasn't just a one-off anomaly. It reflects, I think, the deep strain on infrastructure, where traffic growth is simply outpacing investment and standardization. And when ATC systems fail, they don't fail neatly like a hydraulic pump that has a built-in backup. They can fail ambiguously across organizational boundaries, creating confusion that even the most vigilant pilot cannot resolve because the very inputs they rely on, traffic vectors, clearances, might be corrupted or delayed. We really have to accept that for a fleet this enormous, technical redundancy is, relatively speaking, a well-managed constant. It's the external system fragility that's the escalating variable we need to grapple with.
I appreciate the point about infrastructure lag, I really do. But I'd argue that infrastructure strain itself often increases the probability of technical errors by putting immense pressure on the logistics, the quality control needed to maintain the physical asset, the plane. And that brings us, I think, neatly into contention too, the impact of this massive production expansion. Adding the TNG and FAL designed to significantly raise output, well, it doesn't just put more planes in the sky, it immediately stresses everything upstream, the supply chain, the assembly process itself, and, maybe crucially, the training and standardization of maintenance, repair, and overhaul, MRO practices, especially across a rapidly expanding, very diverse base of global operators. That increased volume, that pressure, translates directly into higher risks of technical lapses. Things like non-conforming parts slipping through, maybe rushed maintenance procedures. These are precisely the kinds of vulnerabilities the NZ-221 crew had to manage. So the rapid introduction of all these new airframes raises technical oversight demands that are incredibly difficult to standardize worldwide. And that, to me, elevates the intrinsic technical risk that we should be prioritizing.
See, I disagree that the primary risk of expansion is technical lapse. The A320 family has sophisticated quality gates, rigorous manufacturing audits. Technical risks, while never zero, are typically bounded. Yes, supply chain stress is real, I grant you that. But the core danger of massive fleet growth, especially into new markets served by facilities like Tianjin, is simply route saturation. It's putting too many planes in the same airspace. More A320s on more routes means exponentially more stress on a fixed airspace capacity.
Just look at the data again. That reduced separation in India wasn't caused by a defective part from a stressed supply chain. It was caused by operational overload. The growth directly exacerbates those handover shortcomings far more dangerously, I'd argue, than it introduces, say, new types of hydraulic malfunctions. When you flood the market with airframes, you inevitably accelerate the interaction risk inherent in a complex, shared environment. And in that environment, a single failure, an ATC failure, can affect dozens of aircraft, not just one.
But isn't the technical integrity of the aircraft the absolute bedrock?
The foundation upon which all these systemic processes have to rely?
Let's imagine an airline operating out of a highly congested hub. They're feeling the pressure. High utilization rates, maybe they start cutting corners, even slightly, on maintenance, a direct consequence of that increased fleet size and operational tempo. That can lead directly to a technical failure. So, the operational pressure acts as an accelerant to an underlying technical vulnerability. Surely we have to maintain focus on preventing that initial technical failure, because it's arguably the only risk factor directly within the manufacturer's and the operator's core control. Systemic risk, well, by its very definition, it requires huge international coordination, billions in infrastructural investment, things that move incredibly slowly. Technical reliability is something we can, and I argue must, police much more tightly today through stricter oversight of MRO and component manufacturing, especially given this production ramp-up.
That's a fair argument about the interaction of these factors, definitely. But I think you might be minimizing the potential severity of a systemic failure compared to a, let's say, modern, typically contained technical failure. Which brings us to the nature of modern failure itself. Technical issues on a mature platform like the A320, look, they are almost always contained. The aircraft usually can land safely, it has redundancy built in. The NZ-221 incident, while serious for the crew, was ultimately contained by the aircraft's design and the crew's skill. Systemic failures, however, involve the dynamic interaction of multiple aircraft like that A320 and the 777F freighter. These failures create cascading risks that's much harder for a single flight crew, no matter how skilled, to resolve entirely on their own. A severe separation incident may be caused by simultaneous failures across two controllers, compounded by poor radar data. That requires immediate and successful intervention from the systemic level, not just one crew's vigilance. A single crew simply cannot solve a macro-environmental collapse on their own.
Okay, but the idea that technical issues on the A320 are somehow benign, I think that's a dangerous oversimplification. Hydraulic failures are never benign. They severely restrict control surface movement, braking capacity. I mean, while the NZ-221 crew landed safely, it was undoubtedly a high-risk situation demanding absolutely precise input. Conversely, when a systemic failure occurs, like poor controller handover or a missed clearance, the aircraft itself is often equipped with secondary layers of technical defense. Think about TCAS, traffic collision avoidance systems. TCAS is a technical system designed precisely to mitigate that kind of external systemic error by providing automatic vertical escape maneuvers. So doesn't this actually show that the solution to systemic risk often lies, at least partially, in leveraging the technical capacity on board the aircraft?
But have you really considered the limitations of TCAS in a truly systemic crisis? I mean, TCAS relies on the technical integrity of both aircraft's transponders and avionics working perfectly. And it primarily provides just a vertical maneuver. What if the airspace is incredibly saturated, making a vertical escape difficult or even dangerous? Or what if one aircraft's transponder is faulty, which is itself a technical lapse, granted, then the systemic defense fails right there. More importantly, though, TCAS cannot resolve ambiguities in clearance instructions or fundamental miscommunications on the ground, which seems to be at the heart of the India airspace incident. It wasn't just about two planes getting too close visually. It was reportedly a breakdown in procedural trust and coordination between ATC sectors. So the systemic vulnerability is the risk of procedure failure, not just physical proximity. And we are placing more and more aircraft into operational environments that are in many places procedurally brittle. That makes the external risk profile for me the unavoidable and most dangerous factor moving forward.
I'd counter that the procedural brittleness you describe is often only truly exposed or becomes critical when either a technical crisis occurs on board an aircraft or when traffic density reaches extreme levels. Technical failure is often the genesis of risk. It's the instantaneous event that demands immediate, singular crew intervention based on deep aircraft knowledge. A procedural error, while serious, can often be corrected over a period of minutes, perhaps. A major hydraulic failure demands resolution in seconds. It represents, I think, a more immediate, singular threat to the people on board, placing the ultimate safety burden right back on the crew's ability to manage that technical failure, which ultimately is the highest measure of true system resilience.
That view works well, perhaps, when you isolate one flight, one incident. But as the Tianjin FAL and others accelerate production, we're moving from optimizing resilience for a single point of failure on one aircraft to needing resilience against network collapse. The 777F separation incident shows us, I think starkly, that the biggest threat now is the interaction risk, the increasing probability that multiple perfectly reliable aircraft will find themselves in danger due to flawed external coordination. We urgently need to invest in smart, global air traffic management systems that can actually match the scale of the A320's deployment. Because simply relying on every single pilot to be the final barrier against what is fundamentally a global infrastructure issue, well, that's just not sustainable in the long run. Ultimately, while of course no one would advocate for ignoring the very real deficiencies in global air traffic management, I still maintain that the safety of the A320 family must fundamentally rest on the inherent technical reliability of the aircraft itself, and crucially, the professional skill of the human crews managing those internal risks. The NZ-221 incident demonstrates pretty clearly, I think, that even the most modern aircraft will present mechanical surprises. And the human response to that failure, not some automated operational system, remains the final and most critical safety barrier. We really must prioritize oversight where the manufacturer and the operator have the most direct control, and that's technical integrity. And my position remains that the A320 is fundamentally a mature, technically robust platform. Its inherent risk profile has, relatively speaking, stabilized over decades. The true danger now is the massive escalation of its external exposure. The rising output capacity, driven by these new final assembly lines, means increasing vulnerability to systemic operational failures. We're talking airspace saturation, deficient infrastructure, procedural fragility, all highlighted quite vividly by that India airspace near miss. This escalating external risk profile demands infrastructural and procedural solutions that go far, far beyond just reinforcing aircraft-specific crew vigilance.
We certainly seem to agree, though, that these incidents provide two very different yet equally urgent lessons for the industry. These simultaneous challenges, maintaining technical rigor while trying to navigate these systemic infrastructural gaps, they really define the complexity of global aviation safety today.
Indeed. It feels like the speed of fleet expansion is currently outpacing the necessary investments in global air traffic control modernization and regulatory synchronization. The source material clearly shows there's a lot more to unpack here, particularly how these two dimensions of risk, the internal technical risk and the external environmental risk, are interacting and perhaps even exacerbating one another as the A320 fleet continues its massive global growth trajectory.